Okay, this is lesson 1.4, solving linear systems, and this time it's by elimination. The way we use elimination to solve a linear system is we stack the two equations that we're looking at in our system, and we add or subtract down the columns. And the way this works is we take both equations and we make them look the same. And what I mean by that is we put all of our x and y terms on one side and our constant terms on the other side, so that they line up on top of each other. And if you look at the examples down here, they've all been already lined up, so we haven't had to do any rearranging. We've got our x term, then our y term, then equals, then our constant term. X term, then y term, then equals, then constant term. Same with the practice one. We've got our x's, our y's, our equals, and our number terms. And we can use elimination when we set up our equations to look like this. Now, it doesn't have to be x and y on one side, constants on the other, as long as it's consistent. Like we could just have y's on the left side and then the x's and constants on the other side. As long as both equations look the same, we can stack them and then add or subtract them. And sometimes we can just stack and add or subtract directly, and that's the first two types. We don't have to do any other math first. The other types we're going to do a little bit later. We'll have to do a little bit of work to make them, to set them up so that we can do elimination. So as we did in substitution, I have the examples up, the steps up here that we can follow along with. I'm going to do an example, we're going to follow the steps, and then I have one for you to practice. So let's dive right in. Let's try an example of elimination. So I'll keep the steps on the screen there. First, we're going to label our equations. We've got equation 1 and equation 2. And we're going to determine which variable we will eliminate by making sure the coefficients of that variable are the same for both equations. So we're going to look at the two equations and see if the numbers in front of the letters are the same. Well, our x's, the coefficients are 1 and 3. Those aren't the same. Our y's have coefficients of -1 and +1, which aren't the same, but they're close enough that we're able to do elimination, and I'll show you why in a second. So the variable we're going to be able to eliminate in this example is the y's, because they have the same number in front of them. Now the signs are the opposite, but it's the same number, 1 and 1, negative and positive, but that's close enough. The reason it's close enough is because the way elimination works is we stack the equations on top of each other, and then we either add or subtract the like terms. And if you can add or subtract the like terms, and by doing so you're able to eliminate one of the variables because they add or subtract to 0, well, then we'll have an equation that only has one variable and we can use it to solve. So in our first example, we're going to stack them. We're going to draw a line underneath, and we're either going to add or subtract down the columns. And the choice of addition or subtraction depends on which choice is going to allow you to add or subtract one of these terms to 0. Well, if we try adding, x and 3x would make 4x, that the x's aren't eliminated. But the y's having the same number in front, -1 and 1, if we add down the columns, -y plus +y would equal 0 y's. And that allows us to eliminate y's. So the type of elimination we're going to do here is actually addition. We're going to add down the columns. So here we go. X plus 3x is 4x. -y plus +y, I'm going to write it, is 0 y's. Equals, line up. -1 plus -7 is -8. Now, 0y, that's not really a term because we don't have any y's. So it's really just 0, so we can cross that out. We don't have any y's. We've eliminated them. So now we just have an equation that says 4x equals -8. And we can solve this for x now by dividing both sides by 4. And we end up with x equals -2. And x equals -2 is actually the x value of the solution to this linear system. It's the x that leads to the point of intersection. And now we can use either equation 1 or equation 2 with what our x equals to find y. So I'm going to sub x equals -2 into, and we can use equation 1 or 2. I'll use equation 1 because I think it looks simpler. So instead of x minus y equals -1, I would have -2 minus y equals -1. And if I want to rearrange that, well, I've got -2 minus y minus 1. If I add 2 to both sides, I get -y minus 1 plus 2. That's moving the -2 over. -1 plus 2 is 1. So we've got -y equals 1. Well, to get rid of the negative, I divide both sides by -1. And I end up with y equals -1. So now I know what x and y are. I can conclude that the point of intersection is -2, -1. So that's the first example of elimination. There's an example for you to practice. If you want to try to practice it on your own because you feel like you got the hang of it already, pause the video and give it a shot. If you would like a little prompt to start, I'm going to do that right now, and then I'm going to ask you to pause the video and try to finish the math. Okay, so for our first practice example, they're already stacked, so the x's, the y's, the equal signs, and the numbers are all lined up nicely. So then we have to ask ourselves, if we add down the columns, are we able to eliminate a variable? And the answer is no, because 5 plus 3 is 8, 2 plus 2 is 4, and the numbers, well, we're not eliminating numbers, we're just trying to eliminate variables. But the coefficients on y are the same, so we should be able to eliminate something, and the way we can do it is by subtracting. So if this is my equation 1 and that's my equation 2, and I subtract down the columns, I should be able to eliminate. And at this point, I'll get you to pause and try to finish the question on your own. Be sure to check the filled-in version on the course website to see if you got the practice 1 right. We're going to move on and try a second type of elimination that's a little bit more tricky of a first step. The second type, if we look at the example 2, we've got 3x plus 5y equals 12, and we've got 2x minus y equals -5. Notice none of the numbers in front of the x's or the y's are the same. So if we try adding down the columns, we don't eliminate a variable. And if we try subtracting, we don't eliminate a variable either. So the key to this question is to be able to get the coefficients to be the same. And the way you can do that, if they're not already the same, is you can multiply one equation by a number so that the coefficients on one of the letters match up. And in this example, the easiest equation to multiply is the second equation. Because if we multiply this second equation by 5, we get a new equation. So everything in this equation multiplies by 5. Take a look at what we end up with. Well, 5 times 2x is 10x. 5 times -y is -5y. And 5 times -5 is -25. We get a whole new equation that if we stack it with our first equation, look what happens. Well, we had 3x plus 5y equals 12. And if we stack our new equation below it, we end up like this. The numbers in front of the y's match up. And since the signs are opposite, we can add down the columns to eliminate. So I'm going to add down the columns. 3x plus 10x is 13x. 5y plus -5y, that's 0y, so we've eliminated the y's. And if we add down this column, we got 12 plus -25 is -13. So we end up with the equation 13x equals -13. Divide away the 13. we get x equals -1. And now that we know what x is, we can put our x answer into any of the three equations, one of the two originals or our new equation, to solve for y. So I'm just going to pick this original 2 equation because the y is kind of already by itself. So I'm going to sub x equals -1 into equation 2. Equation 2 is 2x minus y equals -5. X is -1. A little bit of multiplication. 2 times -1 is -2. Now we want to isolate for y, so we add 2 to both sides. -5 plus 2 is -3, which equals -y. We don't want to know what negative y is, we want to know what positive y is. So we can divide away -1. And that gives us y is equal to 3. So our POI is -1, 3. Now, why did we multiply the second equation by 5? That might be a question that you were having. Well, that was the easiest way to make the coefficients on either x or y line up. Otherwise, we would have been asking ourselves, well, what could we multiply 2 by to make it 3 so that it lines up with 3? And that's a little bit more complicated of an answer because the answer is a fraction or a decimal. We don't really want to work with fractions or decimals. We could have alternatively divided this equation by 5 to make the y's match up, because multiplication and division are the same. We can divide a whole equation by 5, but then we end up with decimals. Now we'd still end up getting the same final answer, but we'd have to work with decimals. So I think the easiest thing to multiply by was the second equation by 5, because that lines up the y's. So I'll get you to try the practice number 2. If you think you're ready to try it already, pause the video now and give it a shot. If you're not, I'm going to get you started by making the 2 equations. Okay, so we have our first equation and our second equation, and none of the coefficients match up. But if we multiply one of the equations by something, we can make the equation, or the y's or the x's match up. And if we look at the y's first, the question would be, what do we have to multiply -4 by to make it 5? And that's kind of a challenging question because, again, the answer is a decimal or a fraction. But looking at the x's, it's a little bit easier to answer the question, because if we take 3x and multiply by 2, we get 6x. So to make these equations match up, we can just take the second equation and multiply by 2. If we do that, we end up with 6x minus 8y equals 12. And then we can stack and subtract or add. And I'm going to leave the rest of it up to you. Once you think you got an answer, make sure to check it on the course website to see if you got it right. And we're going to move on with the third type. In the third type, there's not one equation that we can multiply by something to make them line up. So if we look at our first example here, 5x, there's nothing we can multiply it by to make it 2. Nothing easy. Again, a decimal or fraction could work. Same with 2x to get to 5. We have to multiply by 2.5, and that's decimal. We don't really want to work with decimals. You could if you wanted to. Same thing's true about 2 and 3. We can't just multiply one of them by 2 to make it look like the other one. We'd have to use a decimal then. So in this event, what we can do is we can just pick either x or y, doesn't matter, and we can multiply both equations by something. And what we'll multiply both equations by are whatever numbers in front of the other variable. So what do I mean by that? Let's decide we're going to eliminate the x's. If we want to eliminate the x's, this equation says 5x, and this equation says 2x. We could make both of these equations be 10x if we multiply the first equation by 2 and the second equation by 5. If we do that, the coefficients on x will match up and we can do elimination. Alternatively, if we picked y, we could multiply the first equation by 3 and the second equation by 2 to make the y's both match up with 6 as the coefficient. It doesn't matter which one you pick. I usually try to work with smaller numbers or nice numbers to multiply by, but it's up to you. It's your personal preference. So I said we're going to pick x. Let's actually pick y because I think that it's easier multiplication. So to make the y's match up, we're going to look for a common coefficient of 6. So I'm going to multiply the first equation by 3 and the second equation by 2. I'll try to do all the work at once here. Let's see what we end up with. First equation by 3 would give us 15x plus 6y equals 15. And the second equation by 2 would give us 4x plus 6y equals 26. And if we're going to subtract down the columns to eliminate our y's, because the numbers are the same, we end up with 11x plus 0. I'm going to stop writing the 0y because we don't need to, because it's eliminated. 15 minus 26 is negative 11. And now we're just solving 11x equals negative 11. We can do that by dividing both sides by 11. And we get x equals negative 1. To finish the question now, we can just substitute x into either equation and solve for y. So let's give it a shot. I'm going to sub x equals negative 1 into, let's just pick equation 1. Doesn't matter which equation you pick, you can pick either. So equation 1 is 5x plus 2y equals 5. We could have used this version of equation 1, doesn't matter. We could have used equation 2, we could have used that version of equation 2. Either way, we're going to get the same y value. So let's replace x with negative 1. 5 times negative 1 plus 2y equals 5. 5 times negative 1 is negative 5 plus 2y equals 5. Add 5 to both sides. We get 5 plus 5, which is 10. To get y by itself, divide away the 2. We get y is 5. So, our point of intersection negative 1, 5. And that's 3 different types of elimination. There's another practice question here. I'm not going to set this one up for you. I think if you're at this point and you've been able to successfully complete all the other ones, I bet you can do this one and set it up on your own. If you've been struggling with some of the other elimination methods, don't worry, we're going to spend all day tomorrow in class working on the process of elimination. Type 4, the word problem, we're actually going to save for in class either tomorrow or the next day. So don't worry about that one. But give practice number 3 a shot if you're ready, and I'll see you next time.